Hello everyone, welcome to session 3 of module 2, Test Types, the Targets of Testing. In this session, we will understand the main test types that are involved in software development lifecycle. So let's get started. So test type is focused on a particular test objective. There are 4 main test types. The first type of testing is the functional testing, which tests the functionality of the software. So the testing of a function to be performed by a software is known as functional testing. And this is the first test type in software development lifecycle. Then testing non-functional attributes or quality characteristics of a software like performance, load, or stress is known as non-functional testing. So the second test type is testing the non-functional attributes of a software, which is known as non-functional testing. Then the third test type is testing the structure or architecture of a system or software. So, which is also known as white box testing or a structural testing, because it looks into the code in more detail and can use you need to use different white box test tools or techniques to do the structural testing. So testing the structure or architecture of the software system, that is white box testing, is third test type. And then the fourth test type is testing related to any changes or defect fixes. So main test types in this category is retesting or regression testing. So these are 4 major test types in software development lifecycle, in which you can classify most of your testing types either in one of these 4 categories. So why have we done such a classification? It's just because each of this classification focuses on a particular objective. There is certain objective associated with different test types. So like in functional testing, the objective is to test only the functionality, how the functionality of the software is, whether it is being implemented as per the requirements, whether it meets the end user requirements or not. In non-functional testing, the main objective of testing is to test the non-functional characteristics of the software, like how is the software performing, what's the performance when there are like thousands of users simultaneously logged into an e-commerce website. What is the performance of the website when there are like if you take an example of a website like eBay and Amazon. So these websites are so popular that there are millions of users simultaneously logged in across the globe. So to test the non-functional characteristics of any software is equally important as the functionality of the software. So the objective of non-functional testing is to test how the software performs, or how the e-commerce website, for example, performs when there are so many users across the globe logged simultaneously. Then the third type is the white box testing technique. So that tests the structure or the architecture of the software system, how the design is, and whether all the different like combinations those decision coverage or condition coverage are being met with the test cases, or the statement coverage are being met with the test cases or not. And then testing related to any changes or defect fixes. So usually when you find defects in the software, you raise a defect, and after that defect is fixed by the developer, then you need to retest that defect and make sure that the defect does not exist in the software anymore. So that is known as retesting, because there were some changes required in the code due to that defect fixes, and retesting was required to verify whether that defect has been fixed or not. Then in regression testing, you test if any change in the software, be it with the addition of new functionality or be it by fixing the defect. So any changes in the code does not affect any of the related areas in the software. So just to verify whatever was working before before this fix or before the new functional changes should still keep on working as it was working before. So for that, regression testing is done. Then let's go ahead and understand all of these test types in detail. So testing of function or functional testing, or it is also known as black box testing. So functional testing tests the function of a system or a component. So the main target or main focus of functional testing is to test the functionality of the software as it is defined in the requirement specification or user stories. If the functionality meets the functionality defined by the implemented by the software by the developers meets whatever is defined in the requirement specification document, then your functional testing passes. So it just verifies whether your software meets the functionality as defined in the software requirements specification document. Then functionality of a system is usually described in documents such as software requirement specification, use cases, or functional specification. So functionality is usually defined in SRS, user stories or use cases, and in functional specification document. Then functional testing considers the specified behavior of the system and is often referred as a black box testing. So functional testing just considers the specified behavior. It is not at all considers any internal. It just checks whether the software when executed or when installed and executed meets the functional requirement, and it is not at all bothered about the internal implementation or structure, how that functionality is being implemented. So that is why it is known as black box testing. So you are not bothered about what is implemented, what code is written inside the box to achieve that functionality. So it just so suppose there is a functionality that you provide two numbers for addition, and the output should be the addition of those two numbers. So that's a very basic functionality of the calculator software. So to do functional test, you just need to provide inputs of two numbers and then verify the output. You are not at all bothered about how the internal logic of that addition is implemented in that class or module. So that is why functional testing is also referred as black box testing, because you are not bothered about the internal implementation of any functionality. You just test, you just provide input, you have a set of input test data, and you just test the output and verify whether output meets the specified requirement or not. Then functional testing may be performed at all levels of testing. So this statement means that you can perform functional testing at all the levels, be it on the unit testing levels, um, system testing, so integration testing. So at all the levels you can perform the functional testing. So in unit testing, basically, if there is a class being implemented, say a class which just adds two integers and provides the sum of those two integers. So to functional test that class, the developer can use the functional testing logic, or he can just like write unit test and provide the functional testing attributes and see whether the sum of that class provides the proper results or not. Okay, so functional testing may be performed at all levels of testing. There is no foundation as such that it has to be done only after this level. So you can functional test a unit, you can functional test an integrated unit, you can functional test a whole system, integrated system as a whole. So you can functional test at all levels of testing. Then perspectives of doing functional testing. There are two perspectives. First is requirements based, which uses functional requirements or specification as basis for designing the test cases. Then prioritization is done based on risk criteria mentioned in the requirements document. So the first perspective of doing functional testing is requirements based, in which you just refer to the functional specification document or functional requirement specification document as a basis for designing your test cases, and based on the risks criteria mentioned in the software requirement specification document, you prioritize your test cases based on that risk. Then the second perspective is based on business process. Okay, so in this perspective uses knowledge of business process as a basis for designing tests. So the first one was the requirements base, in which every requirement was mentioned in the requirement specification document, and testers just design test case to match those requirement specifications. But in business process based, it requires your knowledge about the business process. So suppose there is a financial software already being implemented in an industry, and you know how it operates and what are the business requirements that the end users of financial organization need. So you use that knowledge of the business process which is already existing there to design your test cases for any new software or any new implementation that is being done in the banking organization or in the financial organization. Okay, so in the business process based, you use your knowledge of the business process to design your test cases. Then business process describe the scenarios involved in day-to-day business use of a system. So business process also describes how the system is being used in day-to-day activities. So if, for example, everybody might have visited the banks, and if you visit the bank, you can see how the software, banking software, or the software that is being used by the bank employees. So there is a set of activities that those employees perform every day in the bank, like depositing the amount in user's account, disbursing the amount through checks, through payment slips and all. So there is a set of defined business process, that day-to-day business process that is being performed by the banking softwares being implemented in the bank. So any IT person or a business person who is employed in the bank is aware of all the business processes that are being required by that banking software that is being implemented into the bank. Now, if they have to discard the old system and take into the new system or implement the new system into the bank, they already know the business process, they already know the requirements what business processes are involved for the banking software, and that knowledge or that process that a person is already aware of is used for designing the test for any new implementation of the business or of the banking software or a system or a new system that is being implemented into the bank. Okay, then use cases are very useful basis for designing test cases. So in the second type of perspective, that is business process based, so it's basically use cases or end user scenarios or the user scenarios that the bank employees do in their day-to-day activities are very useful in designing the test cases. So these are two perspectives. One is the requirements based, wherein you design test cases only based on the requirement specification documents, and prioritization is done on the risk criteria mentioned in the requirements documents. But in business process based, it requires knowledge of whole business process. It requires interaction with the existing employees and gaining the understanding of the business process or the use cases that those employees use to interact with the system in their day-to-day activities. So these are two perspectives of doing functional testing. Then testing of software product characteristics or non-functional testing. So this is second type of testing. So non-functional testing tests the non-functional attributes like reliability, efficiency, maintainability, usability, etc. So these attributes are all non-functional. Okay, so any testing related to non-functional attributes is known as non-functional testing. Non-functional testing is done with an aim to find how well or how fast an operation is performed by the software. So non-functional testing just focuses to find out how well a system will perform, how well an e-commerce site will perform if there are 50,000 users logged into an e-commerce portal simultaneously. Okay, so these kind of attributes are being tested by non-functional testing. And if there are 50,000 users logged in, then what is the response time that each user will get? So suppose a website is able to handle 50,000 users, but whenever a person tries to load a new page, it takes 30 seconds to load a new page. So that's not a good thing for a website. So non-functional testing tests these attributes. It tests how fast an operation is performed by the software. Okay. Then it may be performed at all test levels. So as for functional testing, non-functional testing can also be done at all different all test levels. So it can be done at unit testing, integration testing, system testing. So it can be performed at all the test levels. It tests how well the system works. Some of the non-functional testing types are like performance testing, load testing, stress testing, then usability, maintainability, reliability, and portability. So these are some non-functional test types. We will cover all these test types in much more detail one by one in further sessions. Then testing of software structure or architecture. So that is also known as structural testing or white box testing. So functional testing was known as black box testing, and if you are testing the structure of a software or architecture of a software, that is known as white box testing, because you are more concerned about the internal implementation of the software, how the classes are being implemented, whether the best practices, best coding practices have been followed or not, and how is basically the internal architecture of the whole software. So that is why it is known as white box testing. So in white box testing or structural testing, it tests the structure or system architecture of the software. Structural testing is concerned about what is happening inside the box, not like the black box testing, in which you were not at all concerned what is happening inside the box. In structural testing, you are more concerned what is happening inside the box, how the code is being implemented, and while the software execution, what is the control flow, what is the decision coverage. So all these types of you are concerned about all these, what is statement coverage, what is decision coverage. So that is why it is known as structural testing and also referred to as white box testing. Then structural testing is done with the help of code coverage tools, which assess the percentage of executable elements that have been exercised or covered. So structural testing requires the access to developers environment, as well as it requires access to the code coverage tools, which you can use to find out what is the percentage of coverage that you are getting with the tests that have been written for testing any module of the software. Then if coverage is not 100%, then additional test cases are needed to written to cover those missed items. So white box testing uses code coverage tool to find out what is the coverage that is being that percentage of coverage that is achieved by the set of test cases that you have right now, and if the coverage is not up to the level which is required for exit criteria, then more test cases are added to cover to get a coverage which is mentioned in the exit criteria. So suppose in exit criteria it is mentioned that 100% code coverage is required, then you need to add the missing test cases so that you get 100% code coverage in white box testing to exit the testing. So testing of software structure or architecture is known as structural testing or white box testing. Then testing related to changes, which is also known as confirmation testing or regression testing. So testing related to changes tests the software whenever there are changes done in the software. For example, when you fix the defects or bugs, or when you implement new functionality in the software. So when is the change done in the software? It's only in two cases: when you are implementing a new functionality or there is a defect which needs to be fixed. These are the two scenarios when you change the code in the software. So whenever you do these changes in the software, testing related to changes needs to be done. If you are fixing a defect, then confirmation testing needs to be done to verify whether the defect that has been fixed is working now and does not exist anymore. When you implement a new functionality in the software, then you need to verify that new functionality that has been implemented is fine. It fulfills whatever requirements were being mentioned in the requirement specification document, as well as it has not introduced any side effects into the software. It has not caused any other failure. So like there is a module which was working before, but due to the defect fix or due to the addition of new functionality, the new functionality is working now. The defect fix has been done and it's working now, but the related module with where the code changes were done is not working now. So regression testing is to find out whether any other part of the code or any other part of the software is not being affected by any addition of new functionality or defect fixes. So testing related to changes has two types of testing. First one is confirmation testing or retesting, and the second is regression testing. So there are two types of testing related to changes: confirmation and regression testing. Confirmation testing is also known as retesting. When it is done, confirmation testing or retesting comes in picture when the test fails and a defect is logged against that test. So whenever a tester is testing a software and he finds he finds that a test has failed, the test has failed, and he raises defect against that test, developer fixes that defect. So once the defect is raised, it is assigned to either development manager, and development manager assigns it to the developer. Developer fixes that defect, assigns it back to the tester. Tester retests that functionality to make sure that the test which failed in previous cycle is now fixed again, is now fixed and working perfectly. Okay, so confirmation testing tests any of the failures or any of the defect fixes done in the software. Then once the defect is fixed and a new build is obtained with fixed defect, retesting is done to make sure that defect has been fixed and test passes now. So retesting tests whether the test that failed in the previous cycle, after being fixed, after getting a new build, the test passes now. While retesting, it is important to follow exactly same steps and use same input data and environment. So while retesting, it is very important to follow exactly same steps that were followed in the first cycle when the defect was found. The reason being, if you follow some different process, then it doesn't make sure that the failure has exactly been rectified, because the first time when you log the defect, the failure, the cause of the failure was because of the steps that you followed or the sequence of steps that are being followed while operating the software. So it is very important to follow the similar steps and make sure that the defect fix does not exist still in the software. And you need to also make sure that same kind of environment, same kind of input and data is being used while retesting or while doing confirmation testing. Then the other testing type related to changes is regression testing. If a defect has been fixed, it might have affected other areas of code. So regression testing is done to find the unexpected side effects of defect fixes. So usually what happens is, suppose there is a module which has a defect, or there is a new functionality being implemented into the software. So whenever a defect is being fixed, there is a code change, some code change required to fix that defect. So that code change might affect some other areas of the code. That's possible. So regression testing is done to find any unexpected side effects of the defect fixes. Then purpose of regression testing is to verify that any modifications in the software have not caused unintended side effects in the software. So the main purpose of regression testing is to verify that there are no side effects being introduced, unintended side effects being introduced by the defect fixes. Regression tests are executed whenever the software changes, either due to defect fix or addition of the new functionality. So it's not like regression test will be performed only when the defect fix is done. It can be done anytime, be it with the defect fix or there is addition of new functionality into the software. So regression tests are executed to make sure that there are no unintended side effects in the software by addition of new functionality or by fixing the defects. Then all the test cases in regression test suites are executed every time and new software version is available. So regression test suite is an ideal candidate for automation. So why is regression test suite an ideal candidate? Because whenever there is a new build available, new version of software available, regression test suite is executed every time. Okay, so that is why in most of the organizations you will see that regression test suite is mostly automated. It's because just to reduce that time and effort and budget, because every time you need to re-execute the regression test case, so it is good to automate that once and use it again and again whenever there is a new version of software available. Whenever you have like defect fixes or a new functionality being added, you can execute the existing regression test suite using automation tool, and you can make sure that no unintended side effects have been caused due to that due to addition of new functionality or defect fix. Then conclusion. To conclude, in this session we learn about different test types like functional testing, non-functional testing, white box testing or structural testing, and testing related to changes, which is also known as retesting or regression testing. Retesting is also known as confirmation testing and regression testing. So functional testing is also known as black box testing. Non-functional testing is testing related to non-functional attributes like performance, reliability, scalability, etc. White box testing or structural testing is testing related to the software architecture, and testing related to changes is retesting whenever you do a defect fix, and regression testing is to test that any defect fix or addition of new functionality has not introduced any side effects in the software. Thank you.